Okay guys, hopefully you have all received your bags that have your egg and your materials in it for the egg drop project that we're going to be doing. This assignment is really for next week, but this week we're learning some of the science behind how to help your eggs survive from a drop. So in your bag you're going to find a certain amount of materials, and those are the only materials that you're going to be able to use in order to make a device that you can put your egg into so that when you drop it from a certain height, it will survive. So that's the goal. You can, in addition to what's in your bag, what I gave you, you may also use some tape and some glue, sparingly, right? But otherwise, just use the materials that I gave you. And that's part of the challenge, is being able to figure out how to use only what I gave you to help your egg survive. So in order to do that with your limited amount of materials, you're probably going to need to understand some of the science. And so that's what we've been doing for specifically this week, when we've talked about momentum and impulse. But also energy is coming into play. So the things that we've talked about over the last couple of weeks are really coming into play here to help you make your eggs survive. And so I want to go over just a little bit more of the science, try to tie it all together and really relate it to this egg drop project that you're going to be doing. So what's all this? Here's the deal. When you drop your egg and it hits the ground, the egg is going to experience a certain amount of force. And that force is probably going to break the egg, right? And so these blocks represent that force. And this ruler right here represents the amount of force that it takes to break an egg. So obviously right now, the amount of force that the egg is experiencing is way more than what it needs to experience to break. And so our egg is going to break. And so in order to get our egg to survive, what we need to do is we need to keep the force below the break threshold. And so there's a couple of ways that we can do that. And we're probably not just going to use one way. We're going to combine our efforts so that we can hopefully get the force below this line. But the first way is just obviously to remove some force, right? And so if I remove some force and the egg experiences less force, then it won't break. But that's a lot of force to try to remove. And so that's probably not going to happen. At best, I may be able to remove a little bit of the force that the egg experiences, but probably not too much. So our other option then is, maybe if we can remove some of it, the other option is to spread this force out, right? So if I can spread the force out into in different ways, then I can keep the amount of force below the threshold. And so what I want to do is I want to talk about how we can spread that force out and keep that force, even though there's the same total amount of net force here, we've spread it out and kept it below what the egg experiences so that it doesn't break. So to do that, I'm probably going to need a whiteboard and some markers, and we'll get things all set up. All right, that's better. Okay, so let's talk about momentum. So momentum is basically mass times velocity. So anything that has mass and it's moving, that means it has momentum. And we use this little weird P symbol for momentum. This stands for momentum. So momentum equals mass times velocity. So when an egg is falling, it has mass, and when it's falling, it does have some speed, some velocity. So it has a certain amount of momentum, right? Okay, so a couple other equations that you've learned through some of your reading and studying this week is this thing called impulse, okay? Impulse is equal to the change in momentum. So if something has some momentum, like an egg, and it falls, and when it hits the ground, its momentum is going to change. In fact, when it hits the ground, it's going to stop. And remember, when an object is moving, it has velocity, then it has momentum. And when it hits the ground, its velocity is going to go to 0. And so its momentum is also going to go to 0. So if it had some momentum, let's say 10, and then it hits the ground and its momentum goes down to 0, its momentum changed by 10, right? The change in momentum. So this is what we define impulse as. Impulse is how much the momentum changes, right? Impulse is also the force multiplied by the time of the impact, okay? And so we can write impulse as force times time. And what we've done here is we've related momentum, which normally is mass times velocity, to force. And that's a good thing because we want to talk about the forces that the egg experiences. Okay, so that's kind of the setup. So here we go. We've got our egg, it's falling, it's got a certain amount of momentum, right? Let's say it's 10. And when it hits the ground, its momentum is going to go down to 0. So its change in momentum is going to be 10, right? And so we could write this as the force that the egg experiences multiplied by the time of the impact, the time that it takes to change the momentum, is going to be equal to 10, because its momentum is going to change 10, right? And so here's the thing. When we have crashes, when we have impacts, we go from some velocity to no velocity, right? And sometimes that takes a long time. Like if I'm driving in my car and I kind of push on the brakes a little bit, eventually I get down to 0. But it took me a long time to get there, right? That's the time that it took for my momentum to have some momentum to 0 momentum. Sometimes that changes really fast. Like an egg in this case, when it hits the ground, slap. It doesn't take hardly any time at all to go from a lot of speed to no speed, right? Like maybe 0.0005 seconds or something. I don't know, really, really small, right? When you smack, the time it takes is really, really small. That time that it takes to go from some speed to no speed or to change its momentum is the time that we're talking about here, right? So to make the math easy, let's just pretend that it takes 1 second when the egg hits the ground to stop. Now, it's a less than 1 second, but again, just to make the math easy, let's call it 1 second, okay? So if I say that the time is 1 second and it's changing its momentum from 10 to 0, or the change is 10, then what would the force be that the egg experiences? Well, let's see. What times 1 is 10? That's easy. 10, right? So the force here in this case would have to be 10. 10 times 1 is 10, right? So the force that the egg experiences when the time is 1 second, so we're going to let time equal 1 second, and the force that it experiences is going to be 10. All right. Is that good, bad? I don't know. Let's try something else, okay? So let's say now that instead of 1 second, I can extend the time of the impact, right? So like pushing on the brakes slowly and I slowly come to a stop, I would like the egg to slowly come to a stop, or at least come to a stop slower than 1 second. Let's say, for example, 2 seconds. Now, we don't know exactly how to do this yet, but let's say that we could make the time longer that it takes to stop. What would happen then? Its momentum still needs to go from 10 to 0, so the change in momentum is 10. But now with the time of 2, so when the time is 2 seconds, what force is the egg going to experience? Well, what times 2 is 10? That's easy, 5, right? 5 times 2 is 10. So if I can extend the time that it takes for the egg to stop, then I have decreased the force. I've actually, by doubling the amount of time that it takes to stop, I've actually decreased the force in half. This is pretty awesome, right? Remember, that's one of the ways that we want to try to help our egg, is to decrease the amount of force that the egg experiences, right? So if we can keep force low, hopefully egg doesn't break. And so we do that by extending the time. So how do we do that? How do we extend the time? Well, again, I keep using this example of in our car pushing on the brakes kind of softly, not too hard, but just kind of pushing on the brakes soft, and it takes us a little while to come to a stop. Well, how do we do that with falling things? Well, we use soft stuff like mattresses and trampolines and things like that, right? If I have a big, thick mattress and I fall off my roof and I land on that mattress, as I hit the mattress, it kind of compresses down a little bit, right? And the whole time it's compressing down, I'm slowing down. I was going really fast, I hit the mattress, and I sink down into the mattress a little bit, and that whole time that I'm sinking down, I'm slowing down. And that is the time it takes for me to change my momentum, the time it takes for me from going really fast to not moving at all, right? And so cushioning, what cushioning does is it extends the time. It extends the time of impact, and so the object experiences less force. Okay, so that's the first thing you want to do for your egg, is you want to extend the time of impact. And you can do that by cushioning. Now, if you watched the video yesterday, you saw a video talking about car crashes and how cars are actually built to crumple. They have crumple zones, and these places where the cars crumple actually extend the time of the impact. And that dissipates some of the energy, it takes up some of the force, and remember what we're doing really here is we're spreading that force out a little bit so the egg doesn't experience all of that force. And so anything you can do to cushion your egg, that's good. Extends the time, less force. Or if you can build in crumple zones into your device, things that will crumple and absorb some of that energy, take some of that force so that the egg doesn't experience it. Those crumple zones also extend the time and as well as absorb some of the force and energy. And so again, we're lowering the amount of force. Okay? So those are a couple of things that you can do. I want to talk about one more thing that we can do, and it's kind of like taking those first few blocks of force right off the top and not even dealing with them. Right? This stuff is kind of spreading the force out. But you can do something to remove some of the force right off the bat. And that comes back to this initial, how did we get this 10 here, right? This 10 was my change in momentum. I had a certain momentum 10, and I brought it down to 0. Well, what if instead of the momentum of 10, we had a momentum of 8? Well, then, even with 1 second, 1 times 8 would be 8, and so our force would be 8, right? If I start with a lower number to begin with, right here, then obviously my force that it experiences is going to be less. So how do I do that? Well, remember, momentum is based on the mass times the velocity. And your egg has a certain amount of mass. And that it is what it is, right? So that's the mass. But so the thing that you can change, though, hopefully a little bit, is the velocity. If you can change the velocity that the egg drops, then you can decrease its momentum, right? So let's say that the egg has a mass of, let's keep the numbers again really easy, let's say 2, and its velocity is 5, then that's kind of how we came up with maybe that 10, right? If I can make it fall slower, maybe so that it has a velocity of 4, then it doesn't have a momentum of 10 anymore. It would only have a momentum of 8. And so from 8 to 0, that changes 8. And then if the time is still 1 second, but now we've changed this 10 into 8, see how I was using orange there, then what times 1 is 8? The force is 8. The force that it would experience now would be 8. So by decreasing the velocity as it's falling, I have also then decreased the amount of force. And if I can decrease the velocity and make the force less to begin with, then when I extend the time, that force will be even lower, right? Okay, so one last thing. When you build your device and you put your egg in it and it starts to fall, that thing falls with a certain amount of momentum. Now the egg of the mass of the egg is what it is. It's going to stay the same, but any extra mass you add to your contraption increases your momentum, right? And so now my egg was 2, but if I build this big device, and now the mass of the whole thing is 4, now I'm dealing with a momentum of 16. Yikes! 16? What times 1 is 16? Well, yeah, 16, right? So now my force is 16. That's way worse, right? So when you increase the mass of the thing that's falling, you are going to increase its momentum and increase the force on the impact. And so here's the deal. You want to keep the momentum as low as possible, which means you need to keep the mass of your device and your egg as small as possible. Now, you need something there to protect the egg, and that's going to weigh something. And so hopefully the benefit of the protection and maybe the cushioning and the extending the time is going to outweigh the change in momentum. But the idea here is you want to keep your device as light as possible and still do the job. The second thing is, if you can do anything to slow down its fall, parachutes, things like that, then that is going to help reduce the amount of momentum from the beginning, right? And so anything that you can do, put on your device to slow it as it falls down, then that's going to be helpful, okay? So what have we learned then? To help your egg survive this fall, we want to do a few things. We need to extend the time of the impact. We do that by cushioning, building in crumple zones. All of that spreads out the force, keeps it below the critical level so the egg doesn't break. The other thing you want to do is try to keep the amount of the momentum that it has to begin with as low as possible. And you can do that in 2 ways. Keep it as light as possible and keep it falling as slow as possible, right? And if you do all of these things and try to apply those into your egg transport device that you're building, you should be able to get your egg to survive. I'm super excited to see how this goes. Today, what I want you to do, after watching this video, I want you to get out a piece of paper and I want you to start to develop an idea about what you're going to design, how you're going to do it. Look at the stuff in your bag, the stuff that I gave you, and see what you can come up with. I want you to draw your design, get a plan, right? Just a plan today. And then next week, you're going to get started building. And once you've built, we'll go into some more detail about what I want you to do and how I want you to drop that and things next week. But for today, again, I want you to be thinking ahead as to dropping the egg. And today your assignment is to just try to design your egg transport vehicle. What are you going to put in your egg in to help it survive? So I hope you have fun with this. I'm super excited to see what you guys come up with. But apply the science and away you go. It's going to be awesome.